of our time is on that first piece, okay? Finding data, cleaning it, creating the features, doing the ETL, and then we get down to modeling and deploying, okay? So the question that I wanted to kind of talk about today or chat with everybody is, can knowledge graphs help this life cycle? And our whole goal is to do AI better and faster than we did before, okay? So let's think about some of the things here. Okay, so everybody's familiar with knowledge graphs, certainly helps with data catalogs. But one other thing that is a new thing in the industry that you may not be aware of is feature stores. Has anybody heard about feature stores before? Okay, a few of you here. Okay, so feature stores is database. You have an offline piece, you have an online piece. And it's the same problem though, right? I'm trying to find data, I'm trying to find features. What's relevant that's in the feature store, okay? How do I do that? Can knowledge graphs help there? So it's certainly on the front end, but it's also on the back end, okay? So as soon as you have a model, you want to deploy it. You want to score that thing as soon as possible, okay? But let's talk about the front end here to start with. Okay, so quick reminder, what's a feature? Think about a house value. What predicts house value? Well, you might say the number of rooms, number of bedrooms. You might say the square footage of the house. You might have some derived features, right? How close is it to good schools? You might have to compute that, okay? So these things are features, okay? Just a quick reminder. Again, so this is the feature store sits in the middle. It's all about after you find the data, you want to build the pipeline, you put it in the feature store, and then you're scoring stuff on the other side. Okay, so we've been working on this. We announced our feature store in September of last year. Hit the Wall Street Journal. It was nice to see. Also, Datanami and other ones there. H2O.ai is our partner in this. You can actually buy the software as a product now if you're interested in that as well. But we've been using it for about 7 months now. Okay. Here's a picture of it. Okay. So each of these things is a feature set. You have account activity, and it might be hard to see on the top there, but we have 179 feature sets, okay? So sets of features for given things, given problems, churn, fraud, whatever, and about 7,000 features, okay? And you're gonna see, that sounds like a lot, but compared to some of our colleagues out there, they have a lot more features, okay? But so that's the issue is, I got 7,000 things, okay? If I'm trying to have a problem, I wanna try to predict churn, and I put in something, so suppose I put in the subscriber phone number. If I find 4,000 other things, how do I figure out what's relevant that I don't have already, okay? So that's the question, okay? Now, I put a couple of things, so as soon as we launch this thing, super quick wins. Remember, it's all about better models faster, okay? I just showed you 2 things here. We had a fraud use case, we had a broadband fiber churn. We've been working on these things for about a year, these models, okay? And we put it into the feature store and we said, do I see anything else that I missed? Now, I didn't have a great semantic search, I didn't have knowledge graph at the time, but just looking at those things, just kind of visualizing them, we found one in a day, a couple hours, okay? Oh, let's try this one, okay? And then in the next day, in between meetings, we improved our fraud use case by 37%. But we were working on that thing for a year, right? And same thing on the broadband fiber churn, we found there's a bunch of stuff on a different product that we didn't have integrated. We had broadband fiber stuff, we didn't have the wireless capabilities. So we said, oh, that's different, let's add that together, okay? So the question is, can knowledge graph help that go faster? Okay. All right, so again, this is the vision or the intent of the feature store. So today, and this is the thing that kind of got us on, why are we doing feature store? I would go to meeting after meeting after meeting, and you have a data scientist, they'd be so proud of their new feature. And every time I scratch on my head, didn't I just see that in the last meeting? Almost the same feature, people are reproducing the same thing, right? So that's what you see on the left, okay? Feature X prime, feature X prime prime, almost the same thing. And they didn't know it, right? Because everything is in silos. So you have 250 folks, right? Different groups, they don't know, okay? So the feature store, you can almost think of it as a water cooler, okay? You're in there, you're sharing, you could see stuff. Okay? Now, remember I said we had 7,000 features? I saw this talk, this is Uber, okay? Look at how many features they had. 100,000 features, okay? So if you're trying to figure out something and you're looking for it, and look at, he even had the same question. How do you choose out of 100,000 different features, what should you actually grab, okay? And then the second one is similar. How do you know that what you're doing is not redundant? It's not the same thing again, right? XX prime, okay? So it's almost the same thing. So this is a common problem. So now here's one other thing. So how do you fix this, right? Well, if you think about knowledge graph, you think about labeling things, you think about categorizing things, okay? But that means documentation, okay? And I don't know if this is your experience. This is my experience. So we've been asking people for years, would you please label the business metadata for your data, okay? And it kind of looks like this. The problem is that the searcher is misaligned on the motivation versus the documenter, okay? The searcher's looking for something. How do I find some feature in this area? And is it the same thing, okay? The documenter, and as soon as we see that, you get the chief data officer, we issue a mandate, everybody please label your data. But you have these things going on, right? And you kind of talk to people offline, you say, well, I understand my data. What's in it for me, right? Or you have the person in the middle, it's like, you know, I got so many deliverables. Are you going to go tell my boss that I have to do this thing? Okay. So you have that problem. And then the worst one is, I don't know if you've seen this, is some people are protective of their data. Okay. This is unique to me. This is my job security. And that's kind of the worst thing to happen, right? So you have this problem, generally speaking. Now here's what's cool. It's not misaligned for a data scientist. So let me explain that, okay? Suppose that you did some hard work to ontology label, put knowledge graph on the stuff that you have, okay? So now a data scientist comes in. Me going in the feature store, 7,000 features, maybe Uber going in 100,000 features. How do I know what's relevant to me? How do I know there's something different there that I don't have? Well, how do you do it? Well, the concept is if the data scientist labels their stuff, maybe they only have 50 features. If they label those, all of a sudden they can see exactly what's different versus what's there, okay? Now, let me illustrate that. So the concept is it filters it out. Instead of 7,000, instead of 100,000, you get, try these 200. So let me just illustrate that, okay? So there's a lot of numbers here. Let me try to walk this through. So the top part is, suppose the data scientist has a feature set. You have 64 features, okay? And let's say that you labeled them, okay? So I have account attribute features, I have device features, other product features, performance features. So they have these groupings, okay? So those are the first thing they did. Now let's say that what's in your feature store is already labeled, and you just did a quick pivot table here, comparing it per attribute, and the things in green are dissimilar from the features that I have in concept. I have no device concept in feature set 1. At least there's more performance features in feature set 3 than there is in feature set 1, okay? Now the concept, why is that useful? Well, that's typically what improves your machine learning algorithm, is you find different concepts, different things, okay? So immediately you can say, oh, now I can see which ones to try, okay? Now that was kind of a level 1 ontology. Suppose you went to level 2, so over on the right. So you broke down account attribute into billing, device, you have other products, you broke that down. So that's kind of the next level. So now you can see even further, all the stuff in the green there, those are the dissimilar ones from what you have, okay? So go after those. Now the concept again is every other time in the past, at least at my experience, this label documentation thing has been really hard to get people to do it, okay? But the nice thing is for the data scientists, it's aligned, okay? And they're motivated to do it, okay? All right, so we talked about kind of finding things that are dissimilar. What about the things that are similar, okay? So you have this problem. You have, because the way that people create data is the metadata is always a little bit different. There's no standards many times. If you have a company that's been around for a long time, you'll see this: account underscore ID, account number, billing account number, account ID, account ABC. Are they all the same thing? Okay. So now you want to understand duplications. So you could do this, right? And this is what we used to do, is we used to say, well, let's compute anything that's categorical. We'll do a bag of words model to see how similar it is. Anything that's numerical, you might do a PCA analysis, you do similarity there. So you can compute that. But if you have to compute it on every one, you have 100,000 features, it's not going to be possible. It just takes too long, okay? Now, the nice thing is, you only need to do that on the things that are similar now. So this is the opposite thing. So now I'm trying to compare. I already know which ones are dissimilar. I'm going to grab those. Now I want to look at what things are at least in the same concept. I want to compare those. Okay. So instead, if you didn't have that, so just in these three feature sets, this is how, that would take you 64 times 48 plus 59 features. That's how many comparisons you'd have to do if you didn't have that. But since I have it labeled with an ontology, I can reduce that down, okay? So I can go to, if I have just on one level of ontology, I reduce it to 1,000. If I have two levels of ontology, I reduce it to about 500, okay? So now I can see, I got the dissimilar. Out of the similar stuff, I have these comparisons, and then you can see, okay, I thought it was similar, but it is a little bit different, okay? All right. So now let's talk about how to ontology label. And I'm going to use a robocalling. Anybody know about the pesky calls? You get the spam calls, right? Okay, so let's talk about that problem. We're trying to do as best we can of that. There's still some slipping by, we know that, but let's talk about that. So let's say I wanted to do an ontology for robocalling. So you'd have the count, you have subscriber, you have the customer telephone number, and then you have two types of spam. You got calls, right? And you got text, okay? So you might label it like this, right? You got time, you got duration, how long was that call over what period of time. You could have different averaging windows, last 30, last 90. So you could label some kind of ontology there, okay? Now, let's say that you wanted to find all of the features that are relevant to this. Well, what you want to do is you want to extract features that have something to do with this ontology, okay? So here's a couple that we had: inbound calls, count 30 days contact, inbound text 90 days, okay? And this is the current feature description. But the question is, can I enhance that will make it more searchable with some knowledge graph, okay? Now, if you could write some code, okay, and this, I'm using relational AI's REL here, just an example, you could actually write the formula for inbound calls count 30 days as follows, okay? So here you see, call has terminal CTN, it's part of a count, has timestamp, period is 30 days, okay? And if you actually had data in the graph, this would be executable, and you'd have the full documentation with, let's call this a recipe, okay? So here's the relevant things. And if you could extract those things, you might say, oh, all of those things are direct off the ontology. Let's put those in the semantics for the feature description, okay? But this might be a little bit hard, right? So unless you actually know this, you spend some time to write it down, you might not know all of these, okay? You might not be able to actually write it, but you might be able to remember some of those ingredients, okay? So maybe you remember these two as an example, and you put those in your ingredient list, okay? So now when I go to search, I'm trying to find stuff relevant for robocalls, spam text. I put in those concepts off the ontology. I'm looking at the ontology, and all of a sudden I get all of those features that might be relevant for that, okay? So it helps in that regard. All right, so now let's talk about, that's still some work, okay? And sometimes you're trying to understand at a broad level, what is this feature set about? Okay. I think this is probably common to everybody here, but inside of our feature store, we have documentation or content. Now, this is stuff that really people want to talk about. When you build a model, you're proud of your model, you do a PowerPoint, you do a video, you talk about it, you write a web page about it. All of that stuff, you throw it in the feature store, that's content that you can mine to see, can you pull out some of the semantics there that will help your search, okay? In addition to all the feature lists that you have in the description, okay? So that's all fair game. So just use NLP and go after it. So here's just an example. I use diffbot here, and I took a 30-minute video of my data scientist, my famous data scientist. He's 82 years old, by the way, at AT&T. This guy that was talking about it, he's super passionate. So he talked about his feature set. He was all into it. I just took the entire 25 minutes. I threw it in diffbot. I says, what can it tell me? I just copied a few of these out. Okay, so this particular feature set is who's going to buy the next thing. The next thing for us is who's going to buy 5G. Okay, and look at what popped out, right? So you see who's likely to buy 5G, and then you start getting some description. They have higher internet speed today. They tend to be in finance, communications technology as opposed to service industries. This one was really interesting. Somehow he talked about the primary key. The primary key is customer telephone number. That was really nice. And they tend to be on Disney, Instagram, and they're young and techie. Okay, who's gonna buy the next best thing? That's what's there, okay? And it didn't take any effort, right? This whole thing about documentation, use that for documentation. And this is not even tuned. This was literally cut and paste in the diffbot, okay? All right. Okay, so now one other thing. When I was looking at our feature store, one thing I noticed is sometimes we're missing the truth sets, okay? Obviously, you have to have, if this is my robocalling ontology, I probably have to have something off the ontology is, was this a robocaller or not, right? Or did they complain of a robocall, okay? See, you can't forget those things on your ontology. Those are gonna be useful. All right. So we're walking around the life cycle here. We spend a lot of time in the first part because that's where most of our time is, okay? So obviously, when you have a graph, you got graph features, okay? Well, certainly in robocalling, and I didn't, draw this in a graph, but what is a robocall? What do robocallers do? They make thousands of outbound calls, almost no inbound calls, right? A lot of times if somebody answers it, it's like 2 seconds and it's gone. So you get all those characteristics, right? So those are your graph features naturally. Then you can find communities of them. So all of those things are natural for graph. So if you have a knowledge graph, you have graph, okay? For us, we're able to flag millions of calls a day that we block, hopefully, and sometimes we flag them, okay? So we definitely use that. This is another one that's obvious for us at AT&T. Our network is a graph, right? It's connected, right? So we have all the houses, we have buildings, they all have internet, broadband, and then you look at the network topology and you see it goes all the way up to the central office and then out to the internet, right? And you can start doing stuff like, well, if I don't see any connections to those end houses, or if we missed it somehow and they start complaining, you can infer that something happened in between that node and the node above it, okay? Because the other node on the top part doesn't have a problem, okay? So that's the inference off the knowledge graph directly off the graph. Very useful. Okay, so now we're walking around the graph, right? We've got graph features. We found out how to find the cool features. You really want to run the machine learning. It's nice to be able to do that in the graph, okay? So if you got something, there's a variety of folks, a variety of ones that do this. This is an example. We did XGBoost with relational AI in the graph directly. Okay. All right, so now let's go to the last part. Let's go to monitor. And there's lots of things I've seen in monitor, but I don't know that I've seen this one, so maybe I missed it. I don't, does anybody ever remember this story? There was an anonymized data set that was put out about taxi drives, taxi rides in New York City, right over here, okay? And they said, well, we're gonna put this anonymized data set out, and what was in it is that they had the starting point, they had the stopping point, they didn't say who the rider was, as hashed, right? And they had whether they tipped or not, okay? And you can see, but there was a data blender that reveals which celebrities don't tip and which ones frequent, places they wouldn't want you to know, probably. Okay. So what happened there? Can Knowledge Graph help with that type of stuff? Here's kind of what I think it could help. Okay. So on the left, you have the data set that was not intended to be de-anonymized. Okay. So you have a person, it's a hashed rider. You have whether they tipped or not, they took a taxi, and they had an endpoint of a location and timestamp. Now, it turns out that there was a different data set that was photos of celebrities that had a same location and timestamp, but it had the person de-anonymized. This is Jessica Alba at this taxi place, right? But so location timestamp was naturally joinable, okay? So now all of a sudden the unintended happened and it was all de-anonymized, and you could see all the celebrities that tipped and those that didn't tip, okay? Not intended, right? So this type of thing could happen. It's something we try to make sure we don't have, de-anonymized person and location in our databases, only when we have to actually do something. So this is something that the knowledge graph could help. You could have that rule, if you have a hashed person, concept, and location, if you see another thing that's joinable, you could say, well, that's going to create de-anonymize, right? So don't do that. Try to prevent that. So you prevent inadvertent of those things, okay? And then this is just the wrap up. Certainly, we have a lot of stuff outside this now, but conceptually, it'd be nice in the future we could run the whole thing in the graph, okay? I think I got a few minutes for questions.
Does anyone have any questions in the room?
Yeah, sorry if you've already covered this, but I'm thinking if you're running ML at some point far in the future where you're doing, let's say, actual deep learning approaches, you would, I presume, not have a feature store preset, but you might do feature discovery. In other words, tell us in this graph, what do we care about?
Yeah, I mean, I was covering the feature store, so I didn't mention it, but certainly, the graph neural networks, that would be there, and you wouldn't have to kind of create them. I would say that for tabular type stuff, which is a lot of things that we do, we typically don't do the deep neural network stuff. We don't find a lot of additional advantage there. But for unstructured stuff, we're definitely do that a lot. Yeah.
Actually, I have a question myself. So for the ontology that you use for labeling the feature set, did you use any open source ontology, or no, they were just like labels that the domain experts added?
This one, so that's something that I'm going a bit back and forth with, I'd say. There's business concepts that I tried to capture because that's how they communicate, right? And when you try to go with something that's straight out of the, the documentation or something, it doesn't resonate as much. So I try to keep it in their language, but I'm trying to figure out what's the right balance there. I don't know the exact answer yet, but yeah. I'm open to advice there.
Sure. Any more questions? So I think that, awesome.
Thank you. I'm curious, you have 7,000 features. Do you think in a year it's going to be 7,000 still?
Yeah,
or is that something, how is it growing?
No, it's growing. It's at least 10% a month, probably more. Yeah. So we have a whole roadmap of all these things that should be going in there. So we'll have to see. But what I'm worried about is I want to make sure that we have something on the front end. Is, do I already have this? Is it super similar? And then does it need to be there, or should I use what's there? So that's why we're thinking about that concept. Yeah.
So yeah.
So I'm just thinking about the volume of data that you have.
Mm-hmm.
How do you scale? I mean, how many nodes do you have in your graph and relationships? And do you do some kind of historical back? Is there some time frame where you roll it out, or?
Yeah. By the way, our network processes 456 petabytes a day. Okay. Then we're not storing all that, of course, but that's the traffic that's going across the network. And we have, more than 100 million customers. So that's kind of what you can think of, that we're trying to understand and do that. But it kind of depends on the use case, how long we store it as well. So it varies. Yeah.
Okay, thank you so
Yep.
much.
All right, thank you all.
Thank you.